No, you do not need a headset in order to use MRTK. In fact, we have several options for you to choose from without a device. So first, when you're building and testing your app, there are two options you can use. The first one is the input simulation feature, and this allows you to test using built-in mouse and keyboard inputs inside the Unity editor. In addition, you can also use the HoloLens emulator, which allows you to test on the PC without having an actual physical HoloLens. And when you want to actually deploy your app, you still don't need a headset for that. In addition to deploying on the popular XR devices, you can also deploy your MRTK app to mobile devices using ARKit and ARCore. And in addition, you can deploy your MRTK app as a 2D app to desktop or to web using WebGL.
Hi everyone, welcome to our talk about how we set things on fire. In our mixed reality app, of course, to teach people how to extinguish those different types of fires and how to handle different scenarios. But before we dive into the nitty-gritty details, let's start with a little introduction. I'm Timmy Kokke, but better known as SourceCute in the Metaverse. I'm a senior mixed reality developer at Velicus, working on our HoloLens apps as well as the portal backend and the database. Outside of work, I'm always coding as well, building games mainly in WebXR. I'm a Microsoft MVP, I blog and stream about developing XR, and I help to run the WebXR Discord. Joost?
I'm Joost van Schijk, senior indeed, with 13 years of development behind belt. 7 years experience in mixed reality. I'm a Microsoft MVP as well, and at this time more or less private tutor for a growing number of mixed reality developers worldwide who apparently want to get to grips with mixed reality development and HoloLens. So, what we're going to do. At Velicus, our CEO used to be a nurse and our CTO a health and safety trainer. And you can see a clear line in the types of applications we develop. Saving lives with goals. Mixed reality applications. Cool. Last year we told you about the CPR app we built. This time we're going to talk about the challenges of learning people to deal with an all-too-common danger, fires. It's almost the same story as with CPR. Company first responders go in training once a year and get a check mark. At some facility in an industrial zone you get first some theory, and if you're lucky you get to play with trainer extinguishers. The problem is, although the fires they let you extinguish are usually real, they're almost gas fires, like mock-up for other types of fires, because some fires are hard to realize or non-repeatable. For instance, you can put a solid substance on fire, like a block of wood or a piece of paper, but A, they may take a long time to become a good-sized fire, and B, once extinguished, cannot be lit again, because they're sudden. Most other fires you will never get to see for practical or safety reasons. I mean, an electrical fire is hard to ignite and even harder to extinguish. And other types of fire are, potentially dangerous or flat out disastrous when the student takes the wrong approach. This could lead to what SpaceX so aptly calls a rapid, unplanned disassembly of the training facility. Most likely the student ending their training and life as a medium rare steak. This all leads to first responders in a company rarely having a real feeling for what a fire actually is and how it behaves. And in addition, some kind of extinguishers are expensive to use, expel environment-unfriendly substances, which of course in case of a real fire is really defendable because a real fire emits more toxic fumes. But well, it's not very realistic. You don't get a lot of opportunity to get some proper training. So we aim to perform, people to have to perform proper procedures in case of fire, recognize different type of fire, and well, this, and of course it should be cheaper because we're Dutch after all. So to this end, we employ the HoloLens 2. I don't think that would be a surprise, but optionally we also use a FireWare Apollo LED training extinguisher. We will come to that later. So, well, we aim to train people's mental muscle memory in their own environment as often as they feel the need, so they won't take actions that they will get themselves or bystanders injured or killed. Because you see, the first instinctual response from people to seeing anything on fire is to throw water on it. In a lot of cases that works. In our app we'll show you a lot of cases where it doesn't work. And it will show you so pretty thoroughly. In addition, you can do a fair bit of training without the actual aid of a trainer, which is a big plus in this time of personnel shortage. And this is the real power of mixed reality. Train for situations and show experiences that are too difficult, expensive, or outright dangerous to create in real life. So, enough commercial talk. Let's go with the meat of things. The key to dealing with a fire, as with everything, is knowing what to do in a certain case. You get trained not only to extinguish fires, but also follow the right procedure. Just as with CPR, just as if you're a pilot in an airplane, following procedure quickly and decisively is what saves lives. But let's be honest, the fires are more fun, and the fires are what makes this app fun, especially when the student does something wrong. And believe me, we had quite some fun making this app. But first, the correct procedure. So, the types of fire you have. Solid substance, we showed in the trash can, a flammable liquid, a burning frying pan, a burning gas leak, an electric fire, that's a burning power strip, and yet to come a burning battery. We're really looking forward to that one. I can't show you all the fires, but I can show you a few, because otherwise it just takes too long. First, the happy flow of extinguishing a solid substance fire. First you place it at a certain location. And then I have a little bit too little room in my house, so it's actually a bit too close to me, but whatever, it's a nice demo.
You will now start extinguishing fires. Use one of the virtual objects to extinguish the fires. There's a solid substance on fire. Extinguish the fire the right way without coming too close to it. Alert your vicinity by pressing the fire alarm. Remove the pin from the extinguisher and perform a test shot by squeezing the fire extinguisher's trigger while aiming straight in front of you at the ground. Extinguish the fire.
So I have to look around the fire to see if it's really extinguished. The fun thing, if you walk back to it, you are dead and the fire extinguishes, ignites again.
Call 999 on the phone in your left palm.
Which emergency service do you require? Fire department speaking. Why are you calling? Are you or other people in danger now?
Intention to do wrong, you get them.
What was on fire? The fire brigade is on its way for follow-up inspections. Check for reignition and make sure you stay out of the smoke.
Ta-da!
Well done. The fire is extinguished.
So this is the simple happy flow of extinguishing a fire. You saw at the end a kind of simulated talk with the fire brigade. Anyway, in the beginning you saw what we call the mise en scène. This means arrangement of the properties. The fire goes on the floor and the extinguisher goes on the wall. We use spatial understanding to recognize what is a wall and what is a floor. Now actually for edge cases, like having to demonstrate in a very large hall far from walls down, you can also place the fire extinguishers on the floor and then they will hover about 1.5 meters or I think 5 feet above it. This kind of degrades the immersive experience, but it's useful for demos. So if you have been paying attention, you can already see some interesting failure cases. This is the liquid fire. This is like a burning fuel. And I tried to extinguish this with water, with a fire hose. And that's not what you should do, because then the fire actually becomes bigger. And it says so. Other one is even more fun. Try to extinguish a grease fire with water. If you try to do it like with a water-based substance like foam, mind you, the best case scenario is that you merely get a kitchen totally ruined. More likely you will start a house fire, and there's a fair chance of getting injured or pretty badly, if not simply get yourself killed. While this looks spectacular and funny, this is also very educational. Mind you, the black blocks you see on the video is a recording artifact. In real life, you only see the fireball. It's really funny. It actually stays below your ceiling. It looks all pretty cool. You can imagine that maybe making such failure cases is a lot of fun. Sometimes a bit too much, because well, this is actually the second version of the explosion. Because yeah, no, I will show you the first one. It was actually more fun, but there's an older user interface. Now, I don't know if you saw it, but we'll get a little bit slow-mo. The pen looks like it was spit out of Mount Doom in Mordor. And this is like the slow. You see one frame where it actually comes back from the floor, from the ceiling, and then it drops on the side against the aquarium from the chair to the floor. And it looks like my colleague had a lot of fun. I like this one better, but yeah, well, we had feedback from a fire brigade officer, and he said, yeah, this is really funny and this is really educational, but that's not what it looks like. Oh, well, artists are never appreciated. This is an electrical fire. Well, let's show it. See. Oh, you didn't see that. Let's try that again. Ah, that's better. So my colleague actually watched Electroboom YouTube videos for research. Oh, you know what I said about having too much fun at work? Anyway, if you don't know who Electroboom is, he's world's dumbest electrician, or pretends to be. He has a hugely successful YouTube channel, mainly containing videos of getting himself on juice. And his most successful video is how not to build an electric guitar. So basically we have 4 types of extinguishers. A foam extinguisher, a CO2 extinguisher, a fire hose, and a lid. The lid is the only way to actually extinguish the grease fire. Although there are actually extinguishers capable of extinguishing grease fires, but those are class F, and they, I think, and these are very special extinguishers, very expensive, and they are only used by the fire brigade. And this is the extinguisher picker that shows you how to move between the various extinguishers. There are also some nice details. You see here the handle, you saw it already moving, but there's also a little gouge on it, and it actually goes down when you use the extinguisher, and the extinguisher can actually go empty. So practical challenges. Not everything worked the first time. You already saw some failure, that is the grease fire. I had developed a very elaborate, and I was very proud of it, of a system to open the nozzle by actually rotating it like you do in real life. A ring of small colliders, if you rotate your hand around the nozzle in the right way, and you could open and close it the jet that way. So turn once is a wide jet, turn twice is a narrow jet, turn back, wide jet, turn back once again, it's closed. Yeah. Of course, I managed to do that well, and my colleagues as well, but it turns out that making the unscrew management with your hand without actually holding something is pretty hard. Also, when you hold a real nozzle, there's almost always a moment at which you wonder which way is open. Well, it's very easy to find. One way it doesn't budge, the other it does. But if you don't have a physical nozzle, you don't think I'm turning it the wrong way, you think this dumb app doesn't work. So in the end, we made it easier. You can tap the nozzle once with the hand you're not holding it. It opens to a wide jet, and the second time it opens to a narrow jet. Closing is not possible anymore. And it works like this. Now tap, tap, and then you can tap, tap with a little bit of delay. So that's it. We have another one, hand tracking with the fire hose. A picture says more than 1,000 words, although this is a staged PR photo. It actually demonstrates the issue very well. Observe how my colleague Danielle holds her hand and where she looks. This is very typical for how people hold a fire hose. A downward outstretched arm, fingers clenched almost with a fist, thumb forward while she looks towards the fire and not her hand. While this makes sense when actually extinguish the fire, look at the danger, it poses HoloLens for a few problems. The hand is at the very limit of the tracking camera's field of view, maybe partially obscured by a sleeve or the arm itself, maybe even moving in and out of the field of view of the tracking camera as well. The net effect is that although HoloLens in most cases still can find the location of the hand, or it does an educated guess, I don't know. It starts to fail badly at determining the actual pose of the hand. And this is, or rather was, instrumental in aiming the hose. It made the water jet gyrate wildly in all directions, and of course this did not happen to us developers, because after years of working with HoloLens, we have almost at a subconscious level the knowledge of its limitations. Of course you need to keep your hand in the field of view, otherwise the HoloLens won't be able to track your hand. So we know that, but 99.999% of humanity is not aware of this fact, and this made the fire hose barely borderline unusable for real people. Yes, so we cheated a little. We keep the last hand position, and if getting a pose fails, we use eye tracking as a fallback, but because somebody looks at the danger, and now I'm intentionally moving my eyes to the left and the right, and then you see indeed the wildly gyrating effect. We call this eye tracking assisted aiming. And then there's this, the FireWare Apollo LED extinguisher. It looks, sounds and feels like reality. We have now created this very sophisticated mixed reality environment where you can place pretty realistically looking fires and try out all kinds of extinguishers. There's one thing we cannot simulate: the physical weight and drag of real fire extinguishers. Then we ran into a company called FireWare in the Netherlands that has the exact opposite problem. They use a projector to project fires on a screen that more or less surrounds you. And the trainee then has to use something like this to extinguish the fire. This works great, but the fires are only to the projections on the screen, so the immersion is not very great. We decided to combine our hardware with our software. So, like I said, meet the FireWare Apollo LED extinguisher. It weighs 9 kilo or almost 20 pounds. Instead of foam or another extinguishing medium, it emits a light cone. It looks and feels exactly like a real extinguisher, only at the top it shows its true nature, the picture at the left. You can see a button to turn it on and off, or reset it because it gets empty. A set of LEDs telling you how full it is, and a MagSafe to connector to recharge it. Now if you connect it to Wi-Fi, it tells the world what's doing by sending it out its status over JSON data, and it does so using UDP. Connect the HoloLens with Fire Plus. Connect the HoloLens with Fire Plus to the same local network, and the result is this. turn the fire extinguisher on. And there you go. Now you might have seen, let's try that again. As soon as I press the button, the real extinguishers, of the virtual extinguishers, are gone. Enough. Now this poses about the same challenges as with the fire hose. Because of the weight of the extinguisher, you tend to hold the nozzle down and out. Also, the nozzle partially blocks the view of the hand. So once again, we use the gaze-assisted aiming to make sure the foam ends up where the user at least think they are aiming. And the end result is pretty neat, as you saw. We now partner with Fireware, and there are already customers using this connection between the real and the virtual. If you are interested, have a look at fireware.nl. Select product category. Select product category training fire extinguishers. They come with a setup manual, are easy to configure. Intercepting UDP messages is not very hard. It can be done using the Windows.networking.io.datagram socket class. I created, of course, an MRTK service for it. The drawback of this approach is that it's native UWP code, so it does not work in the editor, which basically mean build and test on the HoloLens. It takes some time to get it working correctly. Another issue that's very hard to explain to non-technical people, like my CEO. Unlike Bluetooth, there is no such thing as a one-to-one connection from a HoloLens to a fireware extinguisher or the other way around. UDP is a simple network protocol. It just yells, hey, I'm doing something. And it's fire and forget. It doesn't even check if the message actually has arrived. It's a low-level network. So, multiple HoloLenses and running Fire Plus and or multiple extinguishers on one network wreak havoc. Now, of course, there could be pragmatic solutions to it. We have evaluated several of them. But sometimes a simple solution and a cheap solution is the easiest one. Buy a €70 MiFi, like this one, that repeats your internet connections and connect one extinguisher and one HoloLens to it, and the UDP messages are limited to one network and one HoloLens. Other benefit you can easily see. I don't know if you can see that on the left from a little bit left from the battery sign. It shows the number of connected devices, which is very nice because as the Wi-Fi connector and extinguisher is not very powerful, it's hard. It also doesn't give any indication of being connected, and you can now see that the numbers should say 2, 1 HoloLens, 1 extinguisher. Well, with that, I think I've talked enough, and I hope my esteemed colleague Timmy is still awake and is ready to do his part of this presentation. Timmy, take it away.
What? Oh, sorry, I must have dozed off there for a second. Forget it. Let's dive a little bit into the techniques a little and have a look at some of the challenges we faced and how we solved them. Before we go into detail, I want to paint a picture of the challenges we faced. The biggest struggle was performance. We wanted to make everything look as good and realistic as possible, but the HoloLens doesn't come with an RTX 3080 or anything like a PC might. We needed to tone down and optimize things quite a lot to get a decent performance on the HoloLens and find a balance between what looked good enough and still performed well. We were working on the door procedure, one of the modules in the app, where we train you how to correctly open a door. We needed the student to call into the room. How can we detect any speech in various languages? In a moment, I'll explain how we solved that. The last challenge we faced were, well, users. As Joost showed, when talking about the host, for example, we often run into issues where we, as HoloLens experts, find it pretty easy to interact with holograms. But end users just can't get it to work. We've learned that it's often better to just make it as simple to control as possible. Now let's dive a little bit deeper in the performance and visual challenges we faced. After some testing, we found that one of the biggest hit on performance were the particles. They looked okay, but they turned out to be way too performance heavy. We did some testing and figured it might be better to switch to VFX graph for the fires and the smoke in that. Now, one of the biggest differences between these is that the particles are calculated on the CPU and the visual effects is calculated on the GPU. While potentially solving the performance issues, this did provide us with a few new challenges. First of all, we needed to upgrade our application to use Unity's universal render pipeline. But the upgrading process is not very difficult. Part of it is just adding the package and switching the render pipeline in the settings. Also, the MRTK helps you in the progress. For example, with upgrading existing shaders to their URP version. After this, the shaders switch back from a bright magenta to the correct materials. With VFX Graph, we could get very fine control over how we want the fires to render and how they should behave. We, however, lost the interaction between particles and the colliders we used for foam and the interaction of smoke and the spatial mesh. This is a side effect of having the effects being calculated highly optimized on the GPU and having the physics being on the CPU. But on the other side, we could add controls for how the fires would progress and how they would look when they got extinguished, as exactly in the parts where we felt needed. Here's a small example of how a fire is ignited and then growing based on a slider value in Unity. Also, the amount of extinguishing can be controlled with a value. In this example, I'm moving the slider with the mouse, but of course, these values can be controlled from code within the app based on if you are actually pointing the extinguisher towards the fire. As mentioned, with using the VFX graph, we lost the interaction with particles and colliders in the scene. Which brings me to another big challenge, foam. When using a foam extinguisher, you end up with a clear visual indication you use foam. There's foam all over the place. We want to have at least some indication where the foam is on the ground. In one of the very first versions we built of this, we created actual bubbles that stayed on the ground with particles and all kinds of crazy things. This quickly turned out to be a no-go. For a while, we had a version where we drew white on a texture where particles hit, or later where a ray would hit, but none of this was neither convincing nor performing. We ended up with just fading in the texture over time. It's not the most beautiful way of doing it, but it's performant and there is something on the ground to give a visual indication. When we were building the training for the door procedure, we also ran into a nice challenge. There are a couple of safety steps you need to do with a door in case of a fire. For example, feeling the knob with the back of your hand, opening a door while blocking it with your feet, and yelling into the room behind the door to check if there's anyone there. That last one turned out to be tricky. Although the HoloLens supports speech recognition, in that case, you have to tell upfront what you would expect from the user. In the end, we've decided not to go with the speech recognition approach, but just listen to the raw data coming from the microphone and count the times a value within that raw data is above a certain threshold. So this picture kind of visualizes what's going on. The red lines are the threshold, and as long as values stay between these lines, there's not enough audio to detect. This can be background noise or whatever. If you say something or you yell into the virtual room, we detect peaks in the audio and assume this was a student. Of course, it's not watertight, and if, for example, a dog would bark in the background at exactly the point where the student needs to yell, with enough volume, the student would pass at that specific step in the progress. Again, this works good enough, and it works pretty much all the time. The final thing that was a bit of a challenge was to check if the user understood what just happened. We wanted to ask the student a couple of questions, so we built something called the Quizmaster. The Quizmaster ties really nicely into our own code base as well as the MRTK and uses the UI from the MRTK to present questions. The questions, or the answers up to the questions, are shown in random order, where 1 is the correct answer. The question is spoken, in this case coming from the phone. We integrated everything into the call with the emerging servers to completely keep you immersed in the process. In the end, it looks a little bit like Who Wants to Be a Millionaire, but without any lifelines, and unfortunately without $1 million at the end. For the final part of our presentation, I'd like to talk a little bit about another app we built regarding training around fire. In this case, we are not putting let's see, can this run? Yes, there we go. In this case, we're not putting out a small fire inside a house. No, we are actually burning entire physical buildings with holographic fire. This app was built as a proof of concept together with the training center of the Dutch Fire Department and one of the security regions. And the main goal of this proof of concept was to have the officers that needed to be trained more immersed instead of just watching a flat picture or video on a screen of the fire. And then they would need to make decisions based on what they saw in the fires on a real building. Based on this visualization of the fire and smoke in the HoloLens, actors outside and a complete team of firefighters, these officers of duty need to get trained to make very, very hard decisions. For example, in one of the scenarios, there's a fire in the theater, and there's one person who fainted inside and did not come out of the building yet. Colleagues are panicking and asking the officer to please send in a team. But with certain types of fire and smoke development, it could be too dangerous to send in firefighters to save this person. The fire officer needs to decide to not risk more lives and leave this person inside, which is a very, very tough decision to take. In the end, feedback we got from the officers that were able to train with this method was very, very positive. Even with a couple of limitations by the app and the HoloLens itself. The scenario that is used is being controlled from the outside. Different sizes of fire in various places needed to be controlled based on what was happening during the training. So we created a little website that gets data sent over from the HoloLens after scanning a unique QR code to setting up a connection with that site. When a button is pressed in this portal, in this remote, a message is sent through WebSockets to the HoloLens, and that can respond to that message with changing the fire, for example. We have used this remote in other apps as well. And it's really nice to have if you need to control things from outside of the HoloLens, and someone can just look at a phone or a tablet or whatever, being anywhere, and control what is happening inside the applications. To place the building in the real world, we used an obvious spot in front of the building. In this case, there was a tile with a ladybird on top of it in front of the entrance of the theater. It was easy to spot, and that's why we chose that exact location and measured how far the virtual building would be according to that tile. It would have been really nice if we would be able to scan that ladybird to place the model. But in the end, we used a QR code that we can just place on top of that tile, and that would place the building in the real world. To visualize that the building was placed, we used a very, very simplistic model of the real theater. That just showed the contours of the building. Now, you might have noticed that in the first video, there was not this brownish model being visible. That's because we did a little trick. We implemented the option to switch the material on that virtual building from this brownish gray material to actually the same material that is used for the occlusion on the spatial mesh. And that way we were able to hide smoke and fire in places that would be behind the real building. And that made it really necessary to walk around the building and in search for the actual place where the fire was, to get a good picture of what was going on. And one of the biggest problems we ran into was sunlight. When the weather is not the best, the app did run the best. Although having these sunglasses in front of the HoloLens at all times outside really improved the visuals. The tracking was really bad in direct sunlight. When the sun is shining into the cameras of the HoloLens, the tracking would be all over the place. But with the sunglasses and a cloudy sky, it was pretty good. But the sunglasses led to a different problem. Imagine having normal sunglasses on outside when there's no sun. You would take them off. And that was exactly what people were doing while wearing the HoloLens. They would open the visor when talking to people to be able to look them in the eyes and walk around. And then when they needed to see something, they would flip it down. And that constant opening and closing of the visor also turned out to be causing tracking issues. But overall, I must say I'm really impressed how little loss there was in tracking when you walk around the building. Now imagine this building was like 100 meters long. And when you walk around it, you would end up the building would stay pretty much the same place, just walking it out with only that one QR code to start with. I was really impressed how that worked. And that's all we have time for today. I wanted to thank everybody for watching. Don't forget to like this video if you liked it. For questions, I think the best way is to go to the GlobalXR Discord. And if you would like to play with fire, make sure to use our app first to make sure you're doing it safe. Bye-bye.